Okay, so we're going to start looking at scatter plots and function models. You probably have seen a scatter plot before. I'm not sure if you've actually made one up to this point, though. So a scatter plot is just a graphical representation of the relationship between two quantitative variables. Quantitative meaning, remember, quantity, something that we can measure. So in our first example, before I even read it, I'm looking at it and I say, okay, I'm measuring time, years since 2005, and population in millions. So if we read, it says the monarch butterfly is essential to the pollination process of many native and farmed North American plants. These butterflies migrate thousands of miles over several months. A Florida Department of Forestry outpost in Hawthorne, Florida, has been tracking their population since the 2005 migration cycle. So we're given this data. Now, mind you, this is a pretty small set of data. Scatter plots, you can have smaller or larger sets of data to look at. The bigger your set of data, it usually helps you to see a better trend, okay, which helps us to be able to predict something that's happening in the future. Sorry, I could not come up with that word. All right, so make a scatter plot of the monarch's migration cycle. So they already kind of set up our first quadrant graph for us, but we do need to set up our labels. So years, time is almost always on the x. So our x-axis is going to be years since 2005. The label could have just been years, but it's definitely important since 2005, so that needs to be somewhere in there. And then our Ys, our population, again, in millions. Again, kind of important because I'm thinking looking at that 296 butterflies is very few, but no, it's 296 million. All right, so when I go to plot this, I just start with 0 to 96. So up here, 1, 334. What do we count? 2, 231. 3, 253. 496. Whoa. Definite drop that year. 5201. 645. 760. And 833. Whoa, that's quite a decline. Okay, so overall, when you're looking at a scatter plot, we have, again, just looks like a bunch of random dots, but we kind of want to look at it and see what type of model does this display. And what I mean by model, we need to use what we've learned this year. Is this looking like a linear model, a quadratic model, or an exponential model? So when I look at this, I'm seeing everything's definitely a negative trend. Looks like it's going down. I'm going to say probably a negative linear model. I don't think exponential, because exponential is where it would have that exponential curve. So where it decreases really fast and then it would kind of flatten out toward the x-axis. I'm not really seeing that here. So I'm going to say a negative linear model. So what type of model? Linear. What is the predicted population size for 2010? So years, now this is where you have got to make sure you are paying attention to your labels. Years since 2005. Well, since 2005, what year is 2010? So 2010, 5 years later. So an actual, it was about 200 million, but if I'm looking at my trend line is telling me, I don't know, 130, 135 million. But to have a true prediction, what we do is we use this data to try and write and if you come back up here, a regression equation. So when we draw this line in our data, this is called a line of best fit. It's also called a regression line. So we use regression equation because that opens it up, it makes it more broad, so it's not just linear. We can use a regression equation for something quadratic or something exponential as well. So let's say they give us these 4 answer choices and they say, hey, which one best models our regression equation? So remember, linear, we look at this and I think of y equals mx plus b. Okay, so m, that's my slope, and b, there's my y-intercept. So when I look at my line of best fit that I drew, my y-intercept is looking a little bit above 325. Now again, that line is not perfect. I just try to draw it in between everything. So let's see. Okay, so these all say 320, except these say negative 320. That would be really sad if our population was negative 320 million. Yeah, that doesn't make sense. All right, so those two are out. So it's either going to be C or D. So now I want to look at my slope. Now again, we can see that our trend is moving negatively. Our population is decreasing. So the only one that actually makes sense here is D. Okay, it's telling us, now, what is that slope saying? Remember, negative 34 over 1. So negative 34. So our population is decreasing by 34 what? 34 million butterflies every year since 2005. This is a really depressing question, but so if it wants to know what is the predicted population size, we're going to use this equation. So in 2010, so 5 years afterward, I'm just going to go ahead and plug in. So negative 34 times 5, again, because it's in 2010, so that's 5 years after 2005, plus 320. Sorry, I'm looking for my calculator. So 170. All right, so 150 is our predicted population size. But is it 150? No, 150 million. That's a lot of zeros. All right, so our predicted was, using that regression equation, was 150. The actual was 200. So our prediction was a little low that year, but overall, it should kind of average out. Now, when they ask us in what year is the population predicted to go extinct? Well, what does that mean? Predicted to go extinct. Well, that would mean our population would be what? 0. So if our population is 0, that's our y value. So we want to know when is the population supposed to be extinct? So when is our population 0? So I'm going to use my equation again, but we're just going to replace our y with 0. So now I'm solving for x because I want to know how many years is it going to take the population to be 0. So I'm going to go ahead and solve for x. So I subtract 320. And divide. So 9.4 years. So we're predicted to go extinct in, let's see, we started in 2005, so plus 9, so that would be 2014. So into the year 2014, they'll be extinct. That's really sad. Okay, so when you have a scatter plot, you want to look at first, what kind of model does it represent? Does it represent something linear, quadratic, or exponential? Then you want to use what you know about the equations. So when you're trying to figure out your regression equation, so use what you know, thinking about slopes, even your parabolas, your A term, is it a positive parabola, a negative parabola? Same thing with our exponential functions. Do we have a rate of increase or a rate of decay? So that's going to affect your B terms. Your A term is your y-intercept. So think about all those key pieces of those types of equations. That way you can look at your answer options and figure out, okay, well, those definitely don't make sense. So again, this is probably one of the more easy parts, is what type of models are displayed in the following scatterplots? So what do these models look like? Well, my first one, what does this trend look like? Well, it looks linear to me. So that's all you got to do. So how about the next one? Well, here I'm looking and I see a parabola. So that makes it quadratic. The next one, I'm seeing that nice exponential curve. Okay, we can see our data is growing, so that's exponential growth. So you should have a B term greater than 1. So if we look over here, again, kind of seeing that parabola. So another quadratic model. Okay, so again, if you're given some answer options for equations, you're going to look at, well, here I would need a negative A term. Here I would need a positive A term. So coming over here, again, I'm seeing something linear, slightly negative. This next one, so see how quickly it decreases and then kind of hangs out by the x-axis? There's another exponential curve. This one's exponential decay. Okay, now I've got a negative linear trend. And our last one. Looks like it is an exponential growth function. So all you're doing is just looking at those shapes. You just need to be able to recognize, do I have an exponential curve? Do I have a parabola? Or do I have a linear trend? Again, they're not going to be perfect because it's real data that we're looking at here. You just need to figure out what kind of trend is it. All right, well, let me know if you have any questions. Hope you guys have a great week.